Here's our first optimization function, and that's again union by rank. So the find we'll eventually find a better way of doing find, but still, we're focusing on union first because we actually have a little bit more flexibility when it comes to that. Because in this example, we're using the union by rank, which is really actually the size of the tree, or size meaning the number of nodes, including the root, in a given set. So what we're hoping for is that this is a strategy that we're trying to basically we're using the size of two sets, and we're hoping that because one is bigger than the other one, we're actually going to always look at the size of the two, and instead we're going to add the smaller one to the larger one because we're already thinking the larger one's already got, probably deep. Whereas the other way, if we're adding the larger one to the smaller one, well, then we're adding more depth to it, and the larger one may already have a lot of depth to it. So it's the order of really comparing the two trees that we're about to merge or union in our set. And again, the strategy is based on size. We're thinking the smaller tree is going to have a smaller depth than the larger tree, and we're going to add that smaller tree to that larger tree to add no more depth to it than the larger tree already has. So if you can believe that, it's a strategy that's really out of all this. So that's what's going to happen to do, with all of this. And again, we're worried about the depth because the larger the depth, the worse it's going to be for find. So it's the only reason why we're really doing all this. So when we get to this, the array version, all of the items are similar to what we've done before. So what I'm going to show you now is down here is that I want you to take a look at some of the roots. So we'll look at 1 and we'll look at 8. If you look at 1, it has -4, and we actually talked about this before, and that's from the 4 that's being boxed right now. And then at 8, looks like 8 has, 5 of them? Okay. So if we were to merge 1 with 8, or just merge them to get 8 and 1, whatever, we're looking for which one actually has the smallest number of nodes because, again, we're hoping that it has the least amount of levels to go through to do our find. In this case, it happens to be true, but that's why we would go ahead and move the 1 to the 8. So now we're going to start merging the two. Now, again, this is after we've done the find and we've checked that both the set that 1 is currently in and the set that 8 are currently in are completely separate, which they are. Now we go ahead and merge the two. Now remember, in this algorithm, we're not worried about child and root on this one. Remember, there was a union, there was an order to it. This time it's not, only because we're worried about the size. And that's why you see up here at the top here, it's 1 and 8 or 8 and 1. It really actually depends on the size. It's not looking at really the order this time. We know that before we added that arrow in there, 1 had a set of 4 and 8 had a set of 5. So you're going to link that 1 to 8 just because of size. That's it. That's the only reason why you're doing that. Now, in the code that we have down here, notice it's not super hard either because, again, all we're doing is we're updating really node values. 1 was pointing, I think it was -4 because it had 4 nodes in itself. It's a -4, and now it's just 8. So all we're updating is some very easy integers. That's it. And that's all this is really doing too. Now there's an if and else because of which one is greater. There's the less than symbol for that one. Then that the first one was less than the other one. Great. So then we got to connect that first one to the second one. That's exactly what that's doing. Or vice versa. The first one was greater than the second one. So that's all that if else statement is really doing, is just make sure which one's greater than the other one, and then does the appropriate linking of them. Notice it's not even a tree version of this, of just setting up the values in the array. And again, this is completely done by size as the determining factor.